Now it's time for our second talk, and that is from Toner Stevenson, and this is on making them visible, women in astronomy in Australia. Toner is a PhD in astronomy, in the astronomical history, and has been the manager of Sydney Observatory and more recently the School of Humanities at the University of Sydney. Toner.
Thanks, Nick. I'm just pulling my presentation up. Here we go. Right. Hi. Hello, everyone. Maybe someone can spotlight me, please. Thank you. Good. I'd like to acknowledge Indigenous peoples as the first astronomers. Today, I'm coming to you from Gayamagal land. When I searched Google this week for images of Australian astronomers, it was actually heartening to see a solid representation of women. Nick Lom and I recently published some research about gender diversity within the Astronomical Society of Australia since 1966, when the ASA was founded. And we saw that the percentage of women had grown from 4% to 31% as at 2023. We found that the ASA had been proactive in addressing diversity in astronomy in Australia through many initiatives, including the Pleiades Awards that rewards organisations for gender equity and diversity outcomes. This program was initiated by the Women in Astronomy chapter, and it's now administered by the IDEA chapter, Inclusion, Diversity and Equity in Astronomy. And Lisa Harvey-Smith, who you can see on this slide, was one of the people really behind this initiative. However, when you go back beyond 1966, you think that very few women worked in astronomy. You'll likely know all about radio astronomer Ruby Payne-Scott, who was a physicist and a mathematician with CSIR until 1950, when she lost her full-time position when it was revealed she was married. From all accounts, Ruby had strong opinions, and so important was her contribution to radio astronomy that there are now over 60 papers and at least maybe more than 3 or 4 books recognising her innovation in this science. Scholarships, and earlier this year, a Sydney ferry was named after her. This is making Payne-Scott a very public figure. But there are earlier women of note in the history of astronomy in Australia. And today, this presentation, I aim to discuss the challenges in discovering the work using 3 typical case studies. Here are the questions that I ask, some of the questions anyhow. Could he have done that alone? Did the women have any agency? How, if, were the women acknowledged? And who is that anonymous person, sometimes referred to as my wife, my daughter? And I chose in this presentation to not use the married names for the women I have case studied. John Tebbutt was one of the most widely acclaimed and public amateur astronomers of the late 19th century. He had a very well-equipped private observatory in Windsor, just 55 kilometres west of Sydney, and his instruments and his prodigious output have been notably documented by people like Wayne Orchison, Graham White and Ragbir Batal. The publication of astronomical observations, however, required undertaking the onerous job of computing reductions by hand in those days, and in the case of comets, by calculating their positions and orbits. Given this, it is not surprising that when you ask the question, could he have done that alone, to find that Tebbutt employed astronomical computers. From Tebbutt's memoirs, we know that he had sought a competent lad. However, he had experienced unexpected difficulty finding such a person, so he employed 19-year-old Margie Arnold. Tebbutt acknowledged Arnold as having intelligence, quickness, and accuracy as a computer, both in logarithms and natural numbers. Her work is exceptional, he wrote. Arnold was a pupil teacher in the local public school. Her parents worked for Tebbutt. Her contribution was to some extent acknowledged in Tebbutt's reflection on the achievements of Windsor Observatory. He emphasised he did all the observations and the most difficult mathematical reductions, but that the occasional services of an ordinary computer are required. So I donned my gloves and took a magnifying glass to the Mitchell Library and leafed through Tebbutt's logbooks, reading the notes he fastidiously wrote. He wrote about who did what for every object he observed. It was at this point that I was astonished to see the extent of Arnold's involvement over 4 years, from 1886 to 1890. In her first year of employment, understandably, Tebbutt corrected her work. But as she became more confident, Arnold undertook greater and greater responsibility for the reductions of comets and the measurement of comparison stars. In particular, Arnold measured comets Winnick and Fabry, Comet Finlay, comets Davidson and Brooks from 1889, and Barnard's comet, his two comets from 1888 and 1889, and 2 pages of her calculations are pictured here. These are for Brooks' comet. For minor planets, that's asteroids, Juno, Hebe, and Flora, Arnold computed the positions, converted sidereal to mean time, and she produced the final tables that showed the results. Of the 56 pages of reductions of equatorial observations of minor planet Pallas, and that's the 3rd largest asteroid in the solar system, that were made in 1888, half of these were completed by Arnold. So Tebbutt reported to the BAA, British Astronomical Association, that he vowed to give testimony as to her qualifications, and this may indeed have assisted Arnold to secure a permanent position as a teacher at North Broken Hill Public School, where she was promoted to headmistress soon after. She married the headmaster, who was also an amateur astronomer, Farquhar Wallace, and so resigned her position and became known as Mrs. Farquhar Wallace. She is amongst the first women in Australia working in astronomy, but I have not found any images of her. And it seems the extent of her work has become hidden in the archival logbooks. I'll move on to another example now, that of the astrographic catalogue, a global enterprise to photograph and map the stars in the entire celestial sphere down to the 11th magnitude. And this is the reason that from 1896 to 1961, 70 well-educated women at school level, who are called computers, joined the astronomical workforce in Australia. Among these women who I have researched, I've chosen today Prudence Valentine Williams, who worked for 11 years at Perth Observatory, for my next case study. And I asked the question, did women have agency? How were the women acknowledged? In 1907, Prudence Valentine Williams, an outstanding 16-year-old student who gained a gold medal in her leaving exams, was employed as an astrographic assistant. The Perth Observatory logbooks show her leadership in training others, her accuracy, her error management. She understood that the women determined the nature of the stars when they looked at those glass plate negatives. They made decisions about the stellar locations, the magnitude, and they identified double stars. And Prudence was determined to enhance the workplace for women. In the State Archives of Western Australia, I went through a folio of forthright letters written by Williams to Perth Observatory director Harold Kerr-Lewis. In 1913, after a complaint was made by assistant astronomer Clive Nossiter about the women's accuracy and speed, Williams explained to Kerr-Lewis that the 4 women had twice measured, calculated, and prepared for publication 21,221 stars within a 6-month period. She ended her response with, "I'm afraid he cannot show a corresponding amount of work for the same period." You can see she was feisty. She argued that the work was demanding, newcomers required months of training, and her words resulted in Kerr-Lewis lobbying government for a significant increase in the women's wages and acknowledgement of Williams as astrographic supervisor. In 1914, Perth Observatory published 242 new double stars from the astrographic catalogue. In the foreword, Kerr-Lewis acknowledged 4 women, including Prudence Williams, as measuring the double stars, and Williams as being the solely responsible for checking the measurements. In the introduction, it states that it was only those stars considered double by the measurers that had been used. And I took this to mean that it was the women who decided which stars were double stars. They were asterisked, as you can see here. However, when a paper was published later on in 1936, using the data and referring to this publication, it was only the male astronomer who was credited. The photograph on the right is not of Perth, it's of Melbourne Observatory Astrographic Bureau, and it demonstrates the sort of setup the women had at Perth. And I'd have to say, at least the Perth women, unlike those in Melbourne, had a toilet they could use. In 1915, Williams was elected to the Astronomical Society of Western Australia, but her career ceased when in 1918 she resigned to care for her brother who had returned injured from the Great War. By then, 25 of the Perth Astrographic Zone volumes were ready for printing, with the remaining 3 volumes completed by women at Edinburgh Observatory. My final case study is about an unnamed contributor. In 1922, Oskar Ulrich von Willer, Professor of Physics at the University of Sydney, mounted an eclipse expedition to Goondiwindi in southern Queensland. There were 12 expedition members, including von Willer and physicist George Briggs, both seen here. But as you can see in this photograph, there were no women at the eclipse observation site. One of von Willer's main objectives was an experiment that aligned with his research interests in using photoelectric cells for astronomy. He and Briggs aimed to measure the intensity of light of the corona during the various phases of the eclipse. And Briggs published the results in the Astrophysical Journal a year later, noting that his wife was involved in the experiments, but not naming her. The wife was Edna Dorothy Sayce, the first woman to graduate from the University of Sydney in physics. In 1917, she presented a paper about illumination and the conductivity of selenium on photoelectric cells to the Royal Society of New South Wales. This is very aligned with the eclipse experiment a few years later. After completing her degree, Sayce lectured at physics at Sydney Teachers College, and it appears she continued to conduct or support research at Sydney University. Von Willer and Briggs used 2 photoelectric cells that had previously been tested by Sayce at the eclipse. They exposed these during totality, and the readings were taken at regular intervals of the electric currents created when coronal light hit the surface of the cells. And then this was measured by highly sensitive galvanometers. A year later, Sayce used the same cells to measure the light reflected to Earth at full moon. This was to compare the light intensity of the corona to that of the moon. Sayce's chart shows that the corona is 0.42 to 0.45 as bright as the moon. This is still a small amount. It's less than a magnitude. Briggs used her chart. He also used photographs taken by James Nangle at the eclipse and other comparative measures in the paper. He drew the conclusion that the intensity of the sun's coronal light increases as the moon covers the sun, but during maximum totality, the brightest portion of the inner corona was covered and the light intensity was less. Just prior to publication, Briggs and Sayce wed. For a short period of time, Sayce continued to teach, but as her daughter Barbara Briggs wrote in memory of her mother, she abandoned her independent career and she turned to assisting her husband in the research and the time-consuming university matters. Sayce, who was a physics pioneer and a feminist, disliked social hierarchy and encouraged other women, including her daughters, into academia. And she remained an active member of the research community. Nick Lom found that in 1928 she co-led a discussion panel about quantum physics at a conference held in Canberra that helped gather momentum for the formation of the Australian Institute of Physics. She also spoke about nuclear physics at an ANZUS conference. And during World War II, Sayce returned to science teaching. So when researching and analysing history, I've found that reflexivity is important. It's important to recognise one's own views and how society has formed them, and to aim for an autonomous mindset. We cannot recreate the social milieu in which people existed in the past to fully understand the impact of gender stereotyping and conditioning. But we can understand how workplace law had a profound influence in Australia. With the exception of Aboriginal women, Australian women gained suffrage and first voted in 1902. However, that same year, a legal marriage bar restriction on women working in state and federal government departments was instituted. Until it was repealed in 1966, this law had long-standing and dire consequences for both sexes and in all areas of development, including this science. I began this talk on a positive note about the increase in the percentage of women who are members of the ASA and therefore working in astronomy. I conclude on a less positive note, as this is not the same for the percentage of young women studying high-level maths and physics in the classroom, nor for PhD graduates in the field. Both of these areas, as recently noted in this decadal plan for astronomy, are in decline. There are few women in amateur astronomy. I don't have statistics on this, but it definitely is an area worthy of research. The reason I've been motivated to research women in astronomy is about equity and diversity in recorded history. Representation is, I believe, and others like Professor Lisa Harvey-Smith say it is powerful. It's powerful and inspiring in the classroom, and making women visible can have many forms. Naming a ferry is just one. A couple of years ago, Craig Bowers, Heritage Research Astronomer for Perth Observatory, nominated Prudence Valentine Williams to have a minor planet named after her. I'm very pleased to inform you that in 2027, this will happen. Thank you. I have many people to thank, and I've used many sources. I particularly like to thank Professor Nick Lom, Dr. Craig Bowers, and my husband, Ron Stevenson.
Thank you very much, Toner. We've got a few minutes for questions. If any want to put anything in the chat, anybody? It was a great talk. Thank you very much. Maybe you could talk a little bit more about all right. Well, there's a question from Richard de Greece. Do we have statistics on non-binary participants?
We do for the Astronomical Society of Australia, and that is a whole other field that needs to be explored, of course. They're fairly recent statistics, though, as you might imagine, because of the society that we live in. And that's certainly a field that will grow in future years in terms of research, Richard. So it's quite difficult to research that historically without making a lot of assumptions because people were very secretive because of the law and because of other factors in society. So you've raised an interesting question. Thank you.
Well, could you just, as I was starting to ask before, could you tell us a little bit more about the computers who worked at Sydney Observatory on the astrographic catalogue?
Yes, I can, Nick. It's a very interesting story, which I know you informed me of probably almost 2 decades ago now, and I started to look at in detail. The computers, when they began working, they had a separate building that was built actually for the meteorologists. They didn't want to use it, so the women moved in there. That building doesn't exist now. They were quite separate to where the astronomers worked, but there was an interchange, a daily interchange at least, in terms of supervision, giving them the latest work. And again, they worked in pairs like all of the astrographic computers. The model was set up in Paris, actually, by Dr. Dorothea Klump. She set up the first astrographic bureau, and that model was followed around the world at the various observatories that took on the job of measuring the glass plate negatives. It was stop and start, however, because as funding for observatories was under the government, the state governments, that came and went. And so they'd get a good go on and get a lot of work done, and then the funding would be cut and they'd lose some of the people who work there and not have them replaced. And that was one of the reasons why it took so long for the astrographic catalogue to be completed. One of the last women who worked on the astrographic catalogue, Winsome Lillian Bellamy, sadly passed away last year. And I was very, very fortunate to be able to interview Winsome a few times and record her. And a short film was made by the Powerhouse involving Winsome. She was a good age, and even in her late 90s, she was very quick on the mark. She had a good memory, and it was a place that she loved working, and she particularly loved the camaraderie amongst the women and the astronomer, Harley Wood, who she worked for, was a very good employer. So I think probably in conclusion, I have found that the lead astronomers, this was the case in Melbourne as well, were actually very appreciative of the work that the women did, and sort of went almost beyond what was probably the social norm in terms of involvement and acknowledgement of them. That was a very interesting finding in a lot of the research that I've done. Um, they they wanted the women to be well paid, and they wanted them to have careers, to have to be permanent. But it was that damn marriage bar that got in the way. Um, and, Ruby Payne Scott, that's what that's why she had to cease work.
Right. Thank you very much, Toner.
Thank you.